on assignment 15, question 19. And in this case here, you have 2 moles of an ideal monatomic gas, telling us a little bit about CV and CP. So CV, or monatomic gas, is going to be 3 halves R, and CP, you're adding another R because it's CV plus R, so you're going to have 5 halves R in case we need those. Now, if you have 2 moles, it's telling you you're starting at a pressure of 3 atmospheres and a temperature of 350 Kelvin. You're going to expand irreversibly, which is the type of questions, the type of equations we've been using in class. They're all irreversible processes. And adiabatically, which means there's no heat transfer. So heat equals 0. That's what adiabatically means. You're expanding against a constant external pressure of 1 atmosphere until your volume has doubled. So V2 is going to be equal to 2 times V1. You want to find final volume, work, heat, delta U, and T2. So we have to start out with a V2, really. You don't have to, I guess. Yeah, you pretty much do have to if you look at everything you need to find. So V2, case here, equals 2 V1s. But how are we going to find our V1? So V1, this is ideal gas, and you have N, P, and T, plus R. So you're going to have 2 NR T1 over P1. Just watch your units, the only thing you have to watch out for in here. So if we are in atmospheres for our pressure, and you want to keep it in atmospheres, which is perfectly fine as well, then you're going to be using 0.08206 liter atmospheres per mole Kelvin. That's just telling you what volume you're going to have, or what volume unit you're going to have in the end. And so you should end up with 38.3 liters. Now the next part you can go for is the work, because you now know your volume change. Okay. So you can solve for V1 as well. And V1 is 19.1 liters, or 19.15 if you want to keep that decimal. Now for work, equals minus P external delta V. Remember that question of units, you really have to watch out here. And it's okay to use whatever units here, just watch what your units are going to be at the end. We want to have work in joules at the end, okay? So if we're going to use atmospheres here, totally fine. We have external is 1 atmosphere. Our delta V is going to be 19.1 or 19.15. And in the end, out of that, you're going to end up with minus 19.1 liter atmospheres, not joules. I kind of talked about this a little bit in question 17. Be really careful here, and remember how you have to switch from one to the other. And I gave you guys that constant, 101.325. That's joules per liter atmosphere. That can come from 2 different ways. You could have gotten that using your 8.314 over this, if you don't remember that. You can also get it, remember this is Pascal meter cubed, okay? And however many in a liter, so if you want to go Pascal meter cubed over liter atmospheres, so how many pascals there are in an atmosphere? 101,325. And there are 1,000 liters in a meter cubed. So this gets you to that right there. And this is joules, okay? That was just a little bit of an aside, but know you have to switch. That's the most important thing here. So in the end, once you've switched, you should have a work of minus 1935 joules. There, we've crossed 2 off our list now. Next 2 are actually really easy. It looks like a lot of work at first. You see it's not really. So heat, you're told adiabatic. So that equals 0. That means that our delta U equals our work, which is minus 1935 joules. Now we're at T2. How are we going to find T2? Well, you know delta U, and you know your equation for delta U for expansion or compression of ideal gases is always NCV delta T. You have CV because you're told it's a monatomic gas, you know how many moles, and you know T1. And now you have delta U. So you can go ahead and solve for T2. And you should end up with an answer in this case here of 272.4 Kelvin. You could take this a little bit further. In this question, it didn't ask, but how would you solve for delta H for this question? So think about that. Remember, expansion and compression of ideal gases, delta H is always equal to N Cp delta T. And now you've found delta T because you have T2 and T1. You know Cp from the fact that it's a monatomic gas, and you have N. So you could solve for this one as well. And I didn't do that yet, but you guys can go ahead and throw that in there just for practice.